All right, hey guys, today we are going to take a look at doing some practice with writing inequalities and putting them together ourselves and then being able to solve them. So just as a reminder, we did a lesson last time to learn what we were allowed to do to both sides of an inequality symbol. If we had something like 2 is greater than -1, we learned when we did the dice game that we could add whatever we wanted to both sides of an inequality, and that was fine. We could subtract whatever we wanted to both sides of an inequality. That was fine. We learned we could multiply or divide by a positive, but if we multiply or divide by a negative, we had to flip the sign. So that we're going to keep that in the back of our minds during this work and see if we run into any situations where we end up multiplying or dividing by a negative and have to flip the sign. We might not run into any of those today because we don't always, but we need to keep it in the back of our mind just in case. So the goal today is to be able to take a word situation and write our own inequalities with a variable so that we can solve them. So we're on page 20 right now in the packet, and we're going to look at this example right here. It says, Tarek is trying to save $265.49 to buy a new tablet. Right now, he has $40 and can save $38 a week from his allowance. It says, write and evaluate an expression to represent the amount of money he has saved after 2 weeks, after 3 weeks, after 4 weeks. We're just going to do after any number of weeks. How much money does he have? So right now he has how much? Well, he has $40. I'm just going to put it big in the middle here. He has 40 right now, and at any point he saved another $38 per week. So after 2 weeks he'd have 38 times 2, right? After 3 weeks he'd have 38 times 3. After 4 weeks, 38 times 4. So after any number of weeks, he's got 38 per week, 38 times X, or maybe I'll do a W, $38 every week, per week. So this is an expression, because there's no equal sign, right? An expression to represent how much money he's got at any given time. What if we wanted to write an inequality from that? We wanted to write a whole statement explaining what he's trying to get to. So right now he's trying to save $265.49. Well, this is all the money he's saved. If we want an inequality that represents that situation, we need to say that all the money he's saved has to be at least $265.49. Could it be equal to $265.49? Sure. Could he save more than $265.49? Yeah, he could have more than that. He could have equal to it. Could he have less than $265.49 and still be able to afford the tablet, though? No, so he can't have less than it. All the money he has to be greater than or equal to the amount he wants, $265.49. And there we just wrote our own inequality to represent the situation. The money he has is greater than or equal to what he needs to buy that. So if we were to solve this inequality, we'd get what W equals. We'd get the number of weeks that he needs to be able to save in order to afford this. So can we try and solve this really quickly? We know our rules. We know this is like our equal sign, and we know we're allowed to do things to both sides as long as it's not multiplying or dividing by a negative. Then we have to do some work. We have to flip that sign around. So to get rid of this plus 40, we would subtract 40. Let's bring down what's left. 38W, because this 40 goes away, and then we're going to subtract $265.49 minus 40, and we're going to get $225.49. Did we have to flip the sign at all? Did we multiply or divide by a negative? Nope. So that stays there. 38W is greater than or equal to $225.49. And then to get the W by itself, divide both sides by 38. And I need to grab a calculator for this one. So let's try $225.49 divided by 38, and it gives us this crazy number here. We don't have to flip the sign. We weren't multiplying or dividing by a negative. ... 5.9339 ... And this W stood for weeks. So can he really get some allowance after 5.9 something weeks? Probably not. So we just have to interpret this when it's an inequality to see what makes sense for this particular situation. He's not going to save for 5.9 weeks. Would he have enough if he saved for 5 weeks? Is that greater than or equal to 5.9? No, so we have to round up for this one. We have to say he needs to save for at least 6 weeks, because that's the smallest number of weeks that's greater than or equal to 5.9 ... He could save for more. He could save for 100 weeks, and he'd definitely have enough money to buy that tablet, right? He could save for 1,000 weeks. There's an infinite number of weeks he could save as long as it's at least 6 weeks, and then he's going to have enough money. Okay, let's do another situation. We actually don't need the whole rest of this page, and if we flip to page 21, we actually did all of this. This was still this Tarek and his tablet question, and we already answered all of that top half of the page. So now we're really just looking at the example at the bottom of page 21. So bottom of page 21, this one is another question that has this consecutive number problem on there. So this one says the sum of two consecutive odd integers is more than negative 12. Write several true numerical inequalities for this one. All right, so consecutive odd integers, any consecutive odd, that means it's like 1 and 3. Those would be consecutive odd, because consecutive means one right after another, and the next odd number after 1 would be 3. So is the sum of these two, my random example, is that more than negative 12? Is 1 plus 3 more than, greater than, negative 12? Yeah, 4 is greater than negative 12. So do 1 and 3 work in this situation? Sure. Are there any other ones you can think of that would work? What about, 25 plus 27? Those are consecutive odd integers. Is there some greater than negative 12? Well, sure, because any two positive numbers we add together are definitely going to be greater than negative 12. So aren't there an infinite number of combinations I could come up with for this? What about negative numbers? A couple consecutive negative numbers, like negative 1. What's the next smaller number than that? Consecutive in order would be like negative 3. So negative 3 and negative 1. If you add those together, is it still bigger than negative 12? Negative 1 plus negative 3 is negative 4. Yeah, negative 4 is bigger than negative 12. It's definitely more to the right on the number line. So we have so many different possibilities for this. Let's see if we can write ourselves an actual inequality to describe this situation where we could solve it and find out what all the possible answers are. So let's do that down here. It's the exact same situation, but in order to help me write this inequality, I'm going to go back to a tape diagram. Can we do a tape diagram for two consecutive odd integers? Do it the same way we did before. The first integer we don't know, let's call that x. And if there's a consecutive odd number, the next one, is it going to be just 1 more than x? Was 3 1 more than 2? 3 1 more than 1? No. 1 plus 2 got us to 3. 25 plus 2 got us to 27. Negative 3 plus 2 gets us to negative 1. So the next bigger number is going to be x, but not plus 1 this time. It's going to be x plus 2 to get us to the next odd number. So here would be an odd number, here would be 2 more, which would give us another odd number. And we know the sum of those adds together is more than negative 12, is greater than negative 12. So if we translate our tape diagram, our symbols, into math, how many x's do we have? 2x plus 2 is greater than negative 12. That is our inequality to describe this situation. And if we solve this now, it's going to tell us all the different possible values of x, of our smallest number here. So treat this like an equal sign for now. Let's see if we can follow the rules. What can we do to both sides to get the x by itself? To get rid of plus 2, we subtract 2. We're allowed to subtract whatever we want as long as we do it to both sides. It does not mess with our inequality. Be careful here. Negative 12 minus 2 gets more negative, negative 14. And now can we divide both sides by negative 2? Are we allowed to do that? Sure, as long as we're dividing by a positive number, which we are. We're dividing by positive 2. Negative divided by a positive is a negative. So what this tells me is that I can pick any two consecutive odd numbers as long as they are bigger than negative 7. Negative 7 wouldn't work. It's saying you can't do negative 7 as your smallest number, because really then you'd have negative 7 and negative 5. That's the next biggest odd number. And negative 7 plus negative 5 is negative 12. It's not bigger than negative 12. It is negative 12. So that just doesn't work with our situation. All right, so there was another example of a consecutive problem, but this time we threw a little wrench in there and we did consecutive odd numbers instead of just consecutive numbers. All right, let's try and do two more. We are going to go to page 22. Page 22, honestly, we've actually done the top part already. That was all from the consecutive number problem. So we're going to the bottom of page 22, and this is Connor right here. Connor went to the county fair with $22.50 in his pocket. He bought a hot dog and drink for $3.75 and then wanted to spend the rest of his money on ride tickets, which cost $1.25 each. Now, he doesn't have to spend all the rest of his money on ride tickets, but he could if he wanted to. So can we write an inequality to represent the total spent, where R is the number of tickets, of ride tickets he purchased? We don't know how many rides he went on, but let's see if we can represent the situation with an inequality. So what was the total amount that he had? I like to start with a total if I know it. The total was $22.50. Okay, I like to put the total all the way at the end because then we know we can work our way toward it. So could he spend more than $22.50? No, that's all he had in his pocket. Could he spend less than $22.50? Sure, he doesn't have to spend all his money. So what he spends could be less than $22.50, or could he exactly spend? Could it be equal to $22.50? Sure. So let's figure out what he spends so that it is less than or equal to the $22.50 in his pocket. Well, what did he spend already? What's he already locked into? He already bought a hot dog and drink. He already spends $3.75. So if he wants to spend more, he's got to add on the cost of all of these tickets, the ride tickets he's buying. We don't know how many he's buying, but we know each of them are $1.25. So if he bought one, it would be $1.25. If he bought two, it would be $1.25 times 2. If he bought 3, it would be $1.25 times 3. So if he buys X or R, $1.25 times R, $1.25 per ride. So that describes Connor's situation right here. If we wanted to solve this to figure out how many rides he goes on, could we do that? Would we be able to do things to both sides of this inequality? Sure. We would put our line down there. Here's my question for you. Would any of the steps that we took here result in us having to flip the sign? What would we do? Let's just talk through it, not even do it yet, just predict. We would subtract both sides, $3.75 from both sides. So we'd subtract. That doesn't make us flip the sign. Then we'd end up dividing both sides by 1.25. Is that okay? Can we do that? Yeah, we can divide by a positive and we don't have to flip the sign. So everything we would do here would be just like we would do in an equation, and it would look just like all of our other equations have done so far. I'm not going to take the time right now to solve this with you because I know you know how to solve it already, and it doesn't do anything differently with this inequality right here. So we could use this to figure out how many rides Connor can go on. If you'd like to do that, go for it. Go ahead and pause this. You can try it, or you don't have to. My focus right now is, can we write the equations or the inequalities? All right, we've got one last one to do. Can you flip to page 23? And again, we don't need to do the top of page 23, so now we're kind of in the middle, bottom of page 23. This is our last problem. It says, write and solve an inequality statement to represent the following problem. It says, on a particular airline, checked bags can weigh no more than 50 pounds. Oh man, anybody that's ever traveled on an airplane before with a big bag has had to worry about this before and be annoyed at having to make sure that your suitcase doesn't weigh more than 50 pounds, or else the airline charges you an overweight fee or an extra baggage fee for that. So Sally, our friend here, was obviously trying to make sure that she wasn't weighing more than 50 pounds in her airline. It says she packed 32 pounds of clothes and 5 identical gifts. So she must have been going to visit people and wanted to bring them gifts in a suitcase that weighs 8 pounds. Just a suitcase weighs 8 pounds by itself. It must be a pretty strong and good suitcase there, but you've got to take that weight into account too. Can we write an inequality to represent the situation? All right, well, I always start with the total. You guys know me. Is there a total amount that we're trying to get to here? It's going to be that 50. And in this case, we're not trying to get to it. We want to stay beneath that. Could our bag weigh 50? Yeah, it could weigh exactly 50. It could equal 50, or it could be less than 50. Our weight of our bag, but our weight of our bag cannot be greater than 50, or we're going to have to pay an extra charge. So let's see all the things that go into our bag that we want to be less than or equal to 50. So what do we start with? She's got clothes, 32 pounds of clothes. What else is already a given that we can't change? That suitcase already weighs 8 pounds. So 32 pounds of clothes plus the 8-pound suitcase, she's already pretty close here to her 50, right? But then she wants to throw in some gifts, and how many gifts did she want? 5 gifts. Do we know how much each gift weighed? No, so 5 per gift, 5 gifts per however much each gift weighs. So I don't know, G. Could that be the weight of each gift right there? If there's 5 gifts and they each weigh G, 5 times G. So this situation should take into account clothes, suitcase, and gifts, and we hope that's all less than or equal to 50. Could we combine some like terms here? Consolidate this a little bit. What is 32 plus 8? I'm getting 40 plus 5G is less than or equal to 50. Right. So if we solved for this, it would give us what G is, which was the weight of each gift. Let's just do that very quickly because this is going to be some quick math. How do we get the G by itself? Get rid of the 40. Subtract 40 from each side. Bring down what's left. 40 minus 40 goes bye-bye. 5G is less than or equal to. Are we allowed to do that? Do we have to flip the sign? No, we just subtract it. We're allowed to subtract whatever we want without flipping the sign. Equals 10. And then 5 times G, to get rid of 5 times, we do the opposite and we divide by 5. So we get that G is less than or equal to 2, and what did this stand for? We don't want to forget units. 2 what? 2 pounds. So each gift has to be 2 pounds or less, and then she's okay. She'll keep her suitcase under 50 pounds, assuming she doesn't need to buy any goodies to fly back with, any souvenirs or anything else that's going to go into her luggage too. All right, so that gave us some practice with this. You are still working right now on your checkpoint 2 and making sure your page 10 is done if that wasn't done before. And then you will be able to have some PLT time after that. Enjoy, guys. Bye-bye.